So let's go to duration and yield curve. So we'll be looking at duration before going to yield curve. Now, I think this aspect came out last night. So I would I will look at this. Let's see how time permits us to cover this today. So, but we should be done, or we should be able to cover duration and yield curve. So let's look at what is duration. What is duration? Duration is just like a payback period. Duration helps to measure how long an investor's in bond, because we are looking at bond now, how much an investor in bond will wait to recover his investment. Let's say you have invested 100,000 on a bond. Don't forget that bond is related to what? Long time borrowing. Long time borrowing. I was talking about interest yesterday. In our previous topic, I say interest rate. That interest rate, we have short time interest rate and long time interest rate. That long time interest rate is related to what? To bond. So when I'm mentioning bond, yeah, you should know that bond has to do with long time investment, has to do with long time investment, people buying bond and all those. So let's say someone bought a bond. Let's say a company bought a bond, and that bond is 100,000. What duration uh what duration measures is how long will that investors how long will that investor we need to wait before getting his investment back. So duration is not even talking about profit. It's not talking about when he will start making profit. Duration is looking at when an investors how long an investor will need to wait his before getting his investment, or before recovering his investment now. So that's why I say it is similar to payback period. So let's look at this calculation now. Now, if you are making a decision when it comes to bond, let's say an investor has invested in a bond. That means the shorter the period, the better for the what? For the investors. Because if you are able to recover your investment back, that means whatever you now get after the recovery of your initial investment, it will not serve as a profit to you. So now that means you can be given a two bond and you may be asked to make decision on that bond. Now that means the one that is shorter, that has shorter duration, is the one that is viable, or the one that should be invested in. So let's look at this question now. Let's say an investors want to invest in bond X. I'm looking at this chapter I'm solving this question from page 511, SFM, page 511. So we have bond X. We are giving bond X. So we are giving the years for this bond, that it will take what? 4 years. Year 1, year 2, year 3, and year 4. So we are giving the return, the expected return on the investment. That means if you invest in bond X, what you will get? So you will get 10,000 for the first year, 10,000 for the third year. Because the bond will last for 4 years, that means the initial principal will be paid along with the expected return. So that means we have 110. So 110, that means the value of that bond is 100, while the expected return is 10. Am I communicating now? That means the bond will be recoverable, or will be redeemable in year 4. That's why you pay back the principal and the return. I know you should have done this in SBR, or Mr. Ezekiel Kula taught you. So don't forget, we want to calculate duration for this now. So when you want to calculate duration, you apply what we call weighting. You weight the return. Don't forget that the weight will be W, while return is R. The weight, year one will be what? We will call year one. Year two will be 2. Year 3 will be 3, and year 4 will be 4. That is the weight. Am I communicating now? Don't forget, when you add the return together, this plus this plus this plus this should give us 140. I think so. 140. That's the total return now. Now look at it now. So you need to calculate R and W. So R times W. Don't forget that the weight you just apply. If it is 5 years, it will be year 1, year 2, year 3, year 4, and year 5. If it is 6 years, you will do that. But this one is for year 4. So now, return times the weight. 10 times 1, what will that give us? 10. 10 times 2, that will give us 20. 10 times 3, that will give us 30. 110 times 4, that will give us, I think, 44. 440. 440. Add it together. What would that give us? What would that give us? That should give us, I think, 500. Now, there's no need for you to calculate the duration now. So the duration now will be the summation. This is the summation. Summation of RW over what? Return. So what's summation of RW? That's 500 divided by the summation of return, rather, which is 140. So what would that give us, please? What would that give us? What would that give us? It will give us 3 points. Are we together? 0.57 years. Yeah. So it will take 3.57 years to recover your investment. And if we look at what we just calculated now, this bond that we calculated is actually the investment. That means it's going to take 3 to 5 years now. 3.57 years. Now, if you look at Y, let's solve for Y. Let's solve for Y. Let's see. Let's solve for Y. Okay, let me adjust. Let me solve for bond Y. We are giving bond Y too. So let's solve for bond Y quickly, and you see. Hope you can see the board. So let me adjust the board a little bit. Now for bond Y, we have, it is also for 4 years. Here we have the expected return, the return rather. So we have year 1, year 2, year 3, year 4. While the return, we have 20, 20, 20, and 120. Now the weighting, which is W. So for year 1, it will be 1, 2, 3, 4, 2, 3, 4. So we have WR, which is return times weight. So we have 20, we have 40, we have 60, and we have 480. I think so. 480. So let's add it together. Let's find the summation of R. If you add this together, that should be 180. I think so. Summation RW. That's 500. That's 600. Now, let's calculate the duration now. So duration, with what I've been explaining, the duration, don't forget the duration will be the summation RW over summation R, which is 600 divided by what? 180. That will give us what? What will it give us? 3.3 years. So which one should you pick as an investor between bond X and bond Y based on the duration now? Which one?
Bond Y.
Bond Y, because
Please,
it take.
can you adjust the ball downward a bit?
Okay.
Oh, not seeing it down.
Okay, can you see it now? Can you see it? So it's bond Y. This produced 3.557 years. Now it will take 3.57 years for you to recover your investment on the bond. Don't forget, and this it will take 3.33 years. So it is bond Y that is worth investing on now. Now, if you look at this question we just solved, it is actually applicable to non-discounted duration, because we are not calculating the present value of what? Of the return. We didn't calculate the present value of the return. So in this calculation we are looking at, we are just calculating duration without taking the time value of money. That means we didn't calculate the present value of the money. So this has a limitation. This bond we calculated it is called non-discounted duration. This bond we calculated using the duration we calculated for the two bond, it is actually calculated without taking the time value of money. So we don't, that means this what we calculated here is called non-discounted duration. So let's go to discounted duration. So how do you calculate discounted duration? Now I say Macaulay duration or discounted duration takes into consideration or recognize the time value of money. The duration we look at, which is called non-discounted duration, does not consider or recognize the time value of money. So you need to calculate the present value of the money. So let's look at this now. They said, based on the question we are given, am I communicating now? Let's say based on the question we have been, I didn't even supposed to write up that question. So let's say bond X now. They now gave us in bond X, they gave us the cost of capital. Am I communicating? The cost of capital. With a cost of capital, they said is 10%. Let's say is 10%. So they now say we should calculate based on the information we used for our previous question now. So let's now calculate duration. So we have here, we have expected return. We have year 1, year 2, year 3, year 4. So the return I think is 10, 10, 10, and 110. Now, in the exam, you may not be given the return directly like this. So the coupon rate is what you use to calculate your return. I think by now you should know. The coupon rate is what you use to calculate the return, or you can refer to it as the cash flow. Am I communicating? So we are still going to look at that when we get to yield curve. So now we are just assuming this is what is given to us. Are we together now? So now that means for this return now, you need to calculate the expected return. So you need to calculate the present value of this return, because we are giving cost of capital. So we are asked now to discount the return now. So let's calculate the discounting factor at 10%. At 10%. So what is discounting factor? You know how to calculate the discounting factor. 1 all over 1 plus r raised to power n, or 1 plus r minus n. So anyone you choose to pick. So let's continue. So at 10% for year 1, what will that be? For year 1. So let me just pick what is in the material. I don't want to waste time. 0.09, because 1 over 1 plus r is the 10. So that's 0.1. raised to power what? 1. That's n. So it's going to give us 0.909. So for year 2, it's going to give us 0.826. I think so. 826. For year 3, it's going to give us 0.751. And for year 4, it's going to give us 0.6683. I don't want to wait for. So after finding it now, that means you wait now. Don't look for the weight first. Don't multiply the return and the weight directly. Find the present value. So what will be the present value of the return now? The present value of the return. Am I communicating now? What will be the present value of the return? That means 10 times 0.909. What would that give us? 9.09. 10 times 0.826. That will give us 8.26. 8.26. 10 times 0.751 is going to give us 7.51. 110. 110.
75.13.
75.13. Okay, thank you. Now, let's add it together. Don't forget we have added this together. So let's add it together. What would that give us? What will it give us? Oh, yeah. Please add it together. I'm waiting.
99.99.
99.99. So let's now weight it now. Are we together now? Let's now weight it. So weighting. So can you see? Okay. So let's weight it now. Sorry, I want to see whether. Let's weight it. So we have for year 1 it's going to be 1, 2, 3, 4. So let's multiply it now. It's 0.09 times 1. So let's now calculate PV times what? Times weight. Don't forget our weight is W. So present value times weight now is, can you see now? Because of the present value now, it's quite different from the discounted, from the undiscounted, what's it called? Duration now. So this times this, I say this now, is 9.09 times 1 is going to give us 9.09. 8.26.
16.52.
16.52. 7.20. 22.53, right?
Yes.
Okay. Yeah, I'm waiting.
300.52.
Okay. This time is 300.52. So 75.13 times 4. That's what do you call it?
300.52.
0.52. So add it together. Add it together. So I'm going to give an assignment. It's not assignment, it's a past question actually.
381.66.
3 what? Can it be 381? It can't be 381 though. See. 340.66. So look at it now. So this means that for you now, let's calculate our discounted duration now. So our discounted duration will be summation PVW. Am I communicating? All over summation PV. Am I communicating? Are we together? So what's our summation PV bracket W, which we did here? 348.66 99.9. So what would that give us? So 3.549 years. Please put the years. Oh, it's duration you are calculating. Oh, always put the years. So this is for bond. What's it called? For bond Y. For bond X. So can we do for bond Y, or should we just leave it and go to another thing?
Let's go to another thing. We already
Okay. Now let's move now. So let's go to modify duration. Modify duration. So you can calculate for bond X. Are we together now? You can do for bond X. So let's go to modify duration. Sorry for wiping, for not waiting. We still have some things to do. So please just hold on for me. So we have modify duration. Now, what do you mean by modify duration? Am I communicating? Modify duration. Modify duration helps to determine the number of times that the value of bond changes as a result of the interest rate. Am I communicating? You know, when we come to sensibility analysis. Now let's just do it like this. Let's go to the calculation first and explain it. Now, when we say modify duration, how do we calculate modify duration? So the formula for modify duration, let me write the formula and explain what it is being meant for. So it is discounted duration all over 1 plus R. Now, what is discounted? Please, you can see discounted duration, or we call it Macaulay duration. It's the same thing. Discounted or Macaulay duration. So in your material, you may see Macaulay duration. It's still the same thing. Now, so what is that R? That R is what we call our redemption yield. And that redemption yield in bond is refers to as the interest rate. Are you getting what I'm saying now? So in your exam, you may be seeing coupon rate, you may be seeing redemption yield. Are you getting what I'm saying now? Redemption yield. Redemption yield is equivalent to what? To interest rate in bond. When you hear interest rates, that means in bond, we call it sometimes redemption yield. Am I communicating? That's what your R is meant for. Am I communicating? Now let's now look at what do we use modify duration for. We use modify duration to measure how bond price change or react to interest rate. And that interest rate is what we call redemption yield. Am I communicating? How they change. It measures the sensibility of bond price. That means how bond price changed as a result of interest rate or as a result of redemption yield. Now let's now look at this our previous question. Now, what is the for bond X and bond Y? If you look at it, our duration, what's our Macaulay duration or discounted duration when we calculated this? I think it's 3.49 years. I think so. So 3.49 years 1 plus R. What's our R there? What's our R there? Cost of capital. Am I communicating? So you may be seeing cost of capital, seeing interest, seeing redemption yield. It's actually the same. So what's our cost of capital in that question? Don't forget, it's 10%. Don't forget, it's 10%. We use 10% now. So it's 0.1. So what will your modified duration? What will it be now? Yeah. 3.49. That's our discounted duration or Macaulay duration in bond X that we calculated.
3.17.
3.17. So for bond Y, we didn't calculate bond for bond Y. But I'm assuming that what is in the material is right, which is 3.22. That is the duration for bond Y. That means the discounted duration or Macaulay duration for bond Y. We didn't calculate it because we don't want to spend much time on it. So 1 plus R. That R is still our redemption yield or interest rate or cost of capital. What is that? 10%, 0.10. So what it is?
2.93.
2.93. Now, what it means now is that as a result of interest rate, our bond X, am I communicating? Our bond X changes 3.17%. Am I communicating? I said percent. 3.17 times. That's what I want to see. 3.17 times as a result of what? Interest rate. That means the price of the bond, the price or the value of the bond changes 3.17 times as a result of the interest rate of 10%. Do you understand what I just explained now? And also bond Y changes. That means it's the value of the bond or the price of the bond changes 2.93 times as a result of change in what? In the interest rate or in the yield curve or in the cost of capital. Am I communicating now? So now what can you deduce from this? That means the higher the duration, the discounted duration. Am I communicating? Are we together? Are we together?
Yes.
Now
yes.
That means the higher the discounted duration, the more sensitive the interest rate, the more sensitive the price of duration is. Can you see now? If you look at this question now, you will see that this one is more higher. This one is more higher. Can you see now? So because it is higher, the discounted duration is higher, the modified duration will for this bond, it will be more sensitive to interest rate. That means it will be more sensitive to interest rate. That means it will change. The number of times the price of bond will change will be higher for this bond than this bond. Do you understand what modified duration is? So modified duration is used to measure how price of bond or the value of bond changes as a result or reacts or changes as a result of interest rate. Can we move forward?
Yes, please.
Now, you can also predict the change in value. We are talking about change. What modified does is to measure change. All these things will not make sense now until we start solving questions on it now. So let's go to how to predict change in value. So how to predict change in value. How to predict change in value. Now, how to predict the change in value of bond. Are we together now? So this is the formula. So change in price is equals to duration minus duration times change in interest rate or redemption yield times price. That's the formula for you to predict the change in the price of your bond. Am I communicating now? That's the formula to, as a result of change in interest rate. That means if interest rate changes, the value of the bond will also change. Am I communicating? Will change. So we are saying to predict the change in the value of bond, use this formula. Change in price equals to minus D. This our D means it is modified duration of the bond. Why triangle I is change in interest rates. Change in interest rates. Why P is the price, the original price of the bond. The original price of the bond. So minus D. So let's look at this. Let's look at this. So let's say you are giving something like this. Page, let me see. Page 515. Am I communicating? Page 5114 of SFL. So we are giving our duration. Macaulay duration. Don't forget that in your exam, you may not be asked to calculate discounted duration. You may be asked to determine the change in price. For you to determine the change in price now, that means you must first calculate your what's it called? Your Your discounted
Modified,
discounted, yes. So you need to calculate all those. You need to calculate it. Are we together? So you need to calculate your discounted cash, your discounted duration. Now, when we get, I think we are getting closer now, because when we get to bond, there's need for you to calculate what we call the market value of bond to determine it. So I'm going to do that. I think that was done was asked in that past question that was that they set last diet. So I'm going to give you that question to try. It's not that hard, but I will do a video on it. But let's see how it's good now. You are given a Macaulay duration of 3. Don't forget it's 3.49. Macaulay duration. You are given modify duration. Don't forget that modified duration is 3.117, and we are given the bond price. Let's say we are given the bond price of 99. Don't worry, we are going to solve how to calculate the price or the value or the market value of bond. Now they said the change in price of each of the bond is caused by the 0.5 change in interest rate. That means change in interest rate. The change in interest rate is 0.5%. So they now say we should calculate the value of the change. Am I communicating? The value of the change. what is the value that the change costs to the price of the bond, to the original price of the bond. Am I communicating? To the original price of the bond. Look at the original price of the bond. Now, I want to calculate what if you apply this interest rate now, if the interest rate changes. So let's look at this formula. So change in price is equals to what's Macaulay duration. The modified duration rather. Modified duration. This minus D is for modified duration. Don't forget. Modified duration. So that means for you to calculate your modified duration, you must even know your Macaulay duration. That's what I was explaining the other time. So you may be asked to calculate change in value. So for you to calculate change in value, you must, if you are not given Macaulay duration, you will need to calculate Macaulay duration. Use that Macaulay duration to calculate your modified duration. Now, after you have done your modified duration, that's when you can now apply this formula. So what's our modified duration rather? Minus, don't forget minus is in the formula, is minus 3.17 minus 3.17 times change in the interest rate. What will be the change in the interest rate? I want to ask us, is 0.5 right? Am I right?
Percentage. So you have to find.
Yeah, thank you. You know why I just notified that is that, you know, when we get to the exam hall, may have this Z that, okay, let me quickly do it. Forgetting, you just write 0. So you need to divide it. 0.5 divided by what? By 100. That will give us what? That will give us 0.005 times the price, the original price. What's the original price? This is the original price. So 9.99. So what will give us as a result of change? Now in the exam too, you may not be given the change in the interest. You may be given the old interest rate and the what? And the new interest rate. So you need to calculate the difference. Are you getting? This is what they do in exam. This is what they do in exam. They may not give you just like what we have been doing for features and option. Now you guys say it's different from what is in the pack. Now I'm going to do a video today on that. Now what I'm saying is that the change in the interest rate may not be given. So it means that if they give you what the interest rate is before and what the interest rate is now, am I communicating? What the interest rate was before and what the interest rate is now. What the interest rate was before. Let's say the interest rate is let's say 2.5% before, and the interest rate has changed by what? Let's say it has changed to 2.0%. So what is the change in the interest rate now is 0.5%. Am I communicating?
Okay.
Do you get what I'm saying now? This is the old and this is the new. So you may not be giving the change in interest rate directly. You may need to determine the change in interest rate. You understand what I just said now? So what would that give us? What would be the change in the value? So when you are calculating the change in the value, please always ignore this minus. Ignore the what? The minus. Am I communicating? Now, the reason why that minus is there is because there is negative relationship between interest rate and bond price. When we get to bond, when we are calculating the market value of bond, I will explain that. That means if the interest rate increases, that means the bond price what will reduce. Am I communicating? Are we together? So that's why they are just putting that minus there, because of the inverse. What I'm saying is that is because of the negative relationship between interest rate and bond price. That means there's no relationship. There is inverse relationship between them now. What we are saying that if the interest rate increases, the price of bond decrease. If the interest rate reduce, the price of bond increase. Do you get what I just explained now? So don't worry, when we get to bond, when we are calculating the market value of bond, you understand what I'm saying. Because in that question, we use different interest rates. I think we use 5% and use 10%. And you see that the value of bond will change as a result of interest rates. Now, that is why that minus is there. So what do you get? As a change in value of as a result of the interest rate, what do you get? Well, let's be fast. 3.17. 1.58. You put if it is naira, you put naira time because we are getting value. Are you getting one? Is value, is not percentage. What we are calculating is change in value. That is the change in price. What that means, as a result of interest rate now, the bond has changed. Am I communicating? Has changed by what? By 1.58 naira. So if it is naira, you put it. If it is pounds, they put there, you put it. You may also calculate the same thing. So let's look at the characteristics, because when it comes to SFM,
I'm seeing minus 0.158.
That means you didn't join us, or you didn't join us. You are not for. I didn't on my this. Let me just go over it again. Number one is that a bond with longer terms have longer duration. What I'm saying is that a bond. Sorry, I'm going over again. The bond for 6 years and a bond that have 2 years. That means the bond that have 6 years is going to have a longer duration. That means, don't forget, the duration is the number, is how long it takes investors to recover their investment. Now, that means the bond for that has a 6 years period is going to have a longer duration. That's what they mean. So bond with longer terms produce longer duration. So now, 2 is that the duration of a bond is an indication that the price of bond change. The price of bond change as a result of market yield or as a result of interest rates. Am I communicating? Now, what it means that if the interest rate arise, the price of bond will fall. Am I communicating? If an interest rate rise, the price of bond increases. Am I communicating? Now, I'm going to explain that. I don't want to, because if I begin to explain it now, because I'm going to be using 100 to explain. 100. In that 100, there's interest in it. So if interest increases, the price of that bond will reduce. So don't let me explain that now yet. So if the interest rate falls, the price of bond will also rise. Will rise. Now, 3 is that bond with lower yield have a longer duration. Bond with a lower yield have a longer duration. Bond with a lower yield. When I say yield, you can mean interest rate. So you may be seeing yield in your exam, yield, or redemption yield, or interest rate. It means the same thing. So bond with a lower interest rate have longer duration. Are you getting what I'm saying now? If you look at that calculation that we did for discounted duration, we are using 10%. Go and use 5%. If you use 5%, you will see that one that has 5% will produce a longer duration than that of 10%. Am I communicating now? So what I'm saying is that bond with a lower yield have a longer duration. I think they even explain it here. they even explain it. If you look at the material in page 515, they use 5% and they use 10%. 5% and 10%. So the one that has 5% for the same bond, the same value, the same bond, but different interest rates, it produces the bond with lower yield, with lower interest rate has longer duration. Am I communicating? Now, that is 3. That's characteristics. Don't forget we are looking at the characteristics of duration. Now, let's go to the characteristics number 4. Number 4. The bond with lower coupon have a longer duration. A bond with lower coupon. Coupon is the return. So, let's say a bond. Let's say a bond is 1,000, or let me say 100. And they said the coupon rate is, let's say, is 20%. Now, what they are saying is that coupon rate is used to what? To calculate the expected return. And let's say that bond is for, the bond is for 4 years. That means in your exam, they may not give you the expected return. You may need to calculate the expected return here. So it means year 1, year 2, year 3, year 4. What coupon? There's difference between coupon rates and redemption yield or interest rates. Interest rate is what you use, or the redemption yield is what you use to calculate the the discounted factor. Yes. So, but that coupon rate is what you use to calculate the return. Let's say if you want to calculate the return now, that is 20% of 100 is what? 20% of 100 is 20, right? So if it is for 4 years, that means it's going to be 20, 20, and the year 4 will be, you pay the return and you have the expected return on that investment, and both the what? The the principal on the redemption date, which is year 4. So what will it be? The expected return in year 4 now? Eh? Are you guys following me at all? 120.
120.
Okay. But now, that's why this course is being taught. I think it takes time before we look at this course. And because of that is because I know you could have done something similar in all these, IFRS 9. You would do something similar to this in IFRS 9. IFRS 9, you will do, when you want to calculate some things, you will do. Even Mr. Ezekiel could have taught you. So let's go now. Let's move forward now. So please note that coupon rate is used to calculate the expected return. So please, so note this characteristics, that it is duration with bond with lower coupon have a longer duration. Let me look at it now. Let's say we have 20% and we have 10%. The one with 10%, the bond with 10% is going to have longer duration, because when you calculate it, let's say bond 1, bond 2. Okay, I don't have time to be proving this now. So don't forget, let's say the value of the bond is 100 now. Let's say the coupon rate will be 20, 20, 20, and 120. For this coupon rate of 10%, is going to be 10, 10, 10, and 110. Now, if you calculate using the same interest rate, if you calculate the duration for it, this one is going to have a longer duration. Am I communicating? The one with the lower coupon rate is going to have a longer duration. So now let's go to duration of a portfolio. So you may be given a portfolio and you may be asked to calculate the duration for a portfolio. Don't worry, I will soon be through with duration and go properly to So how do you calculate the duration for a portfolio? It's quite simple, it's not hard. So let's go to duration of a portfolio. No, now we are going to duration of portfolio. Now, what we have been solving since is duration of individual individual bond. So you may have a portfolio of bond, meaning that an investors may have invested in not just one bond, or it may be two or more bond. Am I communicating? And don't forget that portfolio is the combination. That means the combination of investments. When you decide not to invest in just put your egg in one basket, that's what they used to explain portfolio. Not putting your egg in one basket, spreading your investment, your money that you want to invest in a bond, you invest it in different bond. Am I communicating? And when you have that, you may be asked to calculate the portfolio of calculate the duration of the bond. And how do you calculate the duration of a bond? It is the weight of the individual bond times the weight of the bond of that individual bond times the duration of the bond. So they will give you the duration of each of the bond in that portfolio. You'll be given, and if you are not given, you will need to solve it yourself. So solving it yourself, you solve it just the way we have been solving duration of the bond in our previous example. So time plus the duration of plus the weight of bond 2 times the duration of bond 2. So if you have 5 bond, it will now be let's say it's 4. I'm just restricting this to just 3. So it may be plus weight of bond 3 times duration of bond 3. If it is 4 bond in the portfolio, it will be plus weight of bond 4 times duration of bond 4 times and so on and so forth. So, but let's look at this question now. We are given 3 bond and we have to calculate the duration of the portfolio now. That means what we are given now to execute this formula, it means we have been given the duration of each of the bond, but we have not been given the weight of the bond. That means the weight, just like what we are used to, it is the weight of individual bond is always 1 plus, year 1 will be 1, year 2 will be 2, year 3. For portfolio, it is not like that because they are different bond, so you can't use it. It is when you are calculating the weight, the duration of individual bond, that's when you use that weight. So what we are going to use to calculate the weight in this question is the market value. So weighting, which is W. So now the market value of bond 1 is what? Is 20 divided by the total market value, which is 100. The weight of bond 2 is going to be 30 divided by what? 100. The weight of bond 3 is going to be, what's the market value? We have 50 divided by what? 100. So after that now, we can now apply this formula, which is weight times what? Duration. Am I communicating? So what is duration now? The duration is 2.5 times 20 times 20 over 100. What would that give us? 20 over 100. 2.5 times 20 over 0.5. So for this now, what is going to have? 3.6 times 30 over 100 is what? 1.08. 3.0 times 50 over 100. 1.5. So applying this formula now, since we have gotten the weight times the duration for each of the bond, what are we supposed to do now? We sum it up. So add it together.
Yes,
3.08.
3.08.
So that is the
0.08.
So that's the duration of the portfolio. Am I communicating? Are we together? Now let's move forward now. I'll quickly rush through this so that we can go to bond, yield curve. So let's look at this now. So project duration as a measure of risk. So I'm explaining what I was explaining initially was that duration, we have been looking at duration in the aspect of bond. Duration can also be used as in capital investment appraiser to measure or to assess the payback of a project. And when we say capital investment, it means that a company may want to buy an equipment and look at the time it will take for that money they have invested into that equipment, the number of years or the number of period it will take for them to recover back the investment. Now, am I communicating? Am I communicating? Now, let's now look at it now. We are looking at duration now being used as a tool for capital investment appraisal. Not only in bond that you can use duration to measure the payback or to assess the payback of a bond. You can also use it for a project, for capital investment appraisal. So it's one of the two. So, but please take this into consideration. Now, let's look at it now. How can you use a bond to calculate? So let's go to page SFM. Page 520. 520. Are you with me? Now look at this now. When you are using duration when you are using duration for a particular investment now, please always take, I will just mention it, I will not explain. Let's say you are giving an investment like this. We all know this. Let's say the year, the cash flow, the annual cash flow. Am I communicating? Let's say the discounting factor has been given to you, but don't let me waste time. So we have year 0, year 1, year 2, year 3, year 4, year 5. Hope you can see the board. Let's say year 0 is the initial investment, the capital outlay. Let's say year 1, they made a loss of 40,000. Year 3, they made a profit of 30. Year 2, 30. The cash inflow is 30. Year 3 is 120. Year 4 is 150. Year 5 is 100. Let me just stop there. Now, they are not saying you should use duration. Am I communicating? Let's ask that you are being asked to use duration. Am I communicating? Now, if you are given something like this and you are asked to use duration to appraise that project, you are asked to use duration to apply that to appraise this project now. Don't forget, we are looking at project duration as a measurement of risk to know whether to know the payback, to assess the payback period for an investment. Now look at this now. Now, in normal, if you want to calculate NPV, you will take into consideration year 1 and year 2, year 0 and year 1, right? Am I right? When you want to calculate NPV, you normally take into consideration year 0 and other years, even though it is negative. Am I communicating?
Yes, sir.
Now look at it now. If you are being asked to calculate duration for this kind of project now, don't forget the project we are looking at is not bond, it's normal project, capital investment. Now look at it now. For bond, you will first start. That means you will take into consideration you will start from the year in which that project started making profits or started making cash inflow. When does the company started making cash inflow? Which year did they start making cash inflow? Year 2. That means you will ignore year 0 and year 1. So they said the discounting factor, let's say the discounting factor is at 10%. Am I communicating? So let's consider the 10%. I'll explain this later. 0.825, 0.7. I'm just trying to explain this now. I won't spend much time on this. Now, you know the weight. Am I communicating? You know the weight. What I say you should do when you are weighting a project, what I say you should do? I say you should start from what? So year 0 will be 0, year 1 will be 1, right? Year 2 will be 2, year 3 will be 3, year 4 will be 4, year 5 will be 5, right? Do you still remember this that I explained previously for individual bond? Are you guys?
Yes, for individual bond.
Yes. So what I'm saying is that when you are not calculating duration now for this project, you will ignore year 0 and year 1. Am I communicating? You will ignore year 0 and year 1. You will start from the year in which that company started making cash inflow. When the cash inflow is positive, the first year when the cash inflow is positive is the year you will start from. So when you start it, you will now begin to multiply the weight. You will know how to do that now. So calculate the NPV first, the present value. So this times this, you know how to calculate the discounted duration, right? So you now calculate the discounted duration for this project now. Any question? Or should we just solve the question? Okay. Since you guys are looking like this now, let me just write everything down and explain. Let me write everything down. So when you are using duration for as a tools for capital investment appraisal, if you are given a question like this, that means let's say the cash flow. This is the cash flow. Now for duration now, that means before you calculate now, you will first determine the year in which the company started making positive cash flow. Which year did they start making positive cash flow? Year 2. Don't forget that year 2. What we are saying is that you will not ignore any figures from year 0 and year 1. That means you will not take it into consideration when calculating your duration. That's what we mean. You will not take it into consideration when calculating your duration. Now, what we now say is that calculate the NPV from year 2 now. So 30 times 0.826. That will give us what? 30 times 0.
24,780.
24.
780.
24.
780.
Now, what will now be the weight for year 2? So that means for year 1, don't forget you will ignore year 0 and year 1. So what will be the weight for year 2? So it will be 2. Don't forget, it does not change. It does not mean that you start from weight 1. So weight 1, weight 0, weight 1. So weight 2 will still remain weight 2. Weight 3 will still remain 3. Weight 4 will still be 4. Weight 5 will still be 5. Weight 6 will still be 6. That means ignore is 0 and 1. Am I communicating? So for this times this will give us what? 90. That's 120 times 0.751. So let me just now, since we have calculated, you know how to calculate our discounted duration. Discounted duration now, for us to calculate it, it will now be the present value times what? Times the weight, right? So 24,780 times 2 will give us what? 49,560. Okay. Now 90,120 times 3.
270,360.
270,260.
360.
Okay, 360. Yeah. Now look at it now. Let me just stop there now. Now I want to ask a question now. Let's say we have minus here. Let's say we have something like this. The cash flow is negative in year 0, year 1, year 2, and year 4. Which year are you going to start calculating your duration?
We start from year 3. Year 3 will be 3.
Now, that means you will start from year 3. You are right, sir. Mr. Ibrahim is right. You start from year 3. That means you start from the year that, okay. You will start from the year that first produced a positive, the year that first produced the positive what? Cash flow. Regardless of whether there is negative cash flow in subsequent year, let's say year 4 and year 5, you are still going to take into consideration year 4 and year 5. But assuming, let's say we have negative cash flow from year 0 to year 5, which year are you going to start?
Year 6.
Year 6. Let's say we have positive cash flow and we have, okay, let me just do it like negative, positive. Now, which year are you going to start to calculate your duration? Year 2. Am I correct?
Yes, sir.
Even if all the remaining year is negative, you are going to start from year 2. The first year that what? You start from the first positive cash flow. Am I communicating?
Yes.
Do you get it now? So you now start calculating your duration. And which kind of duration are you going to calculate here? Discounted what? Duration. And discounted duration is called Macaulay what? Duration. Yes. So don't let us dwell much on that. So let's move to the EID curve now. EID. Now, what did I call EID the other time? I said it can be also be referred to what? Redemption yield or interest rate, right? Now, what is yield curve now? Am I communicating? Yield curve helps to show yield curve show or is the relationship between the length of borrowing and the interest rate. That means the relationship between length of borrowing, that means the period of time for borrowing, and the interest rate. That is what we describe as yield curve. Am I communicating? Are we together? Now,
Relationship between what?
Relationship between the length of borrowing and interest rate. So don't forget, I told you that when you hear yield, it means you can, in your exam, they may write interest yield. It may be redemption yield. It may be interest rate. It's still what? The same thing. So look at it now. This is how normal yield curve looks like. Normal yield curve look like this, and I will explain. Don't worry, I will explain now. Normal yield curve look like this. We have yield. Don't forget that yield is what? Is the interest rate, yield, which is always in percentage. And we have what we call time to maturity or length of maturity. That means the period. Now look at this now. We have something like this. This is how it look like. Normal yield curve look like this. Now let me explain what it means. Now let me explain what this curve means. This curve means that for an investor now, when you invest in a bond, it means you are putting your money, you are giving your money to the company, and the company will use the money to invest or to expand their business or to do whatever they want to do with it. Now that means if an investor wants to invest, am I communicating? Now let's say this is year one, and this is year two. That means as the length of the bond is increasing, the interest will also be increasing. What they mean by that? What we mean is that the what's it called? The investors. Let me give an example. Investors will want to demand for high yield for a longer period. Let me give an example. That means if I want to invest 100 million now, and that 100 million is for 1 year, and the same person want to invest 100 million, 100,000 rather, for 3 years. What we are saying is that the person, because of the length of maturity of the investment of the bond now, will want to demand for higher what? Interest. Am I communicating? He wants to demand for higher interest because of the time of the time of maturity of that bond. Are we together now? So investors normally demand for higher yield for longer time to maturity. Do you understand what I just explained? Do you understand what I just explained?
Yes, sir.
Now let me look at it now. Look at it from here. They said interest rates are normally higher for longer maturity. The interest rate for longer maturity is higher. And the reason why it is higher is that to compensate the lender, that means the investors, for tying up his fund for a longer period. Are you guys what I'm saying now? For tying out, that's why you see that when you want to put your money in fixed deposit account, for people that use all this app, I think I've done that for what's it called? For Wema Bank. I think I've tied. That means the longer the period, the higher the interest they will give to you. So you may want to put 1 million you may want to fix 1 million. I'm just giving an example. You want to fix 1 million for 1 month. I may also want to fix the same 1 million for 12 months. I will have higher interest. That means the interest they will give me, it will be going to be higher than yours, because your own may be 5%, while mine may be 7%. The reason why that is done is to compensate the investors or the lender for tying up his fund for a longer period of time. Are we together? Are we together? Now let's now go. There's something we call inverse yield curve. Inverse yield curve. Inverse So inverse yield curve is just the opposite of this now. It's the opposite of this. So you have something like this. Now, someone should ask me, why is this inverse yield curve? What can cause this inverse yield curve? What can cause this yield curve to be inverse? Now, who can tell me the interpretation of this graph that I've drawn now? Who can tell me? For this now, let me give you an example. Now, this inverse is just saying that the longer the length of maturity or time to maturity, the lower the yield. That means the yield is dropping as the length to maturity is increasing. What can cause this now is that if it is forecast or expected that the interest rate in the future will drop. Are you getting what I'm saying now? If it is expected or it has been forecast that the interest rate, the yield in the future will reduce, what will happen? Are you going to be, if one person wants to tie money for 3 years and you know that the interest rate will be reducing, are you going to charge an high interest rate for that for that bond or for that investment? Am I asking? I'm just asking. Are you getting what I'm saying now? You are going to charge a lower interest rate because you are expected that the interest rate in the future will reduce. So what can cause inverse yield curve is when we are expecting that the interest rate in the future is expected, the interest in the future is going to drop. Am I communicating? It's going to fall. So if it falls, it means the length of maturity, as the length of maturity is getting longer, the yield will be will be falling. I've answered the question now. So you are given a question, and this question is derived from page 522. So I'm going to solve for bond B. So I don't want to waste time on bond for bond A. So we'll do for bond B. So what I'm saying is that let's look at this now. You may be asked to calculate the market value of a bond. Now, meaning that the bond, you may be given some bond, you may be given a particular question and asked to calculate the market value. And the reason why you need to calculate the market value of a bond, so that you know how to price that bond. How to value the bond. Now, look at it now. Now, you have been given the yield curve. Let's now calculate now. And the number of years is 4 years. The nominal value of the bond is 100. Why the coupon rate is is 5%. Yield is 7.87%. So number of years, the year first. Now we'll calculate the cash flow. What's the expected cash flow? Now, what did I say we should use when calculating the cash flow? Coupon rate. Thank you. So we have year 1, year 2, year 3, year 4. That means the maturity date for this bond is going to be year what? Year 4. So what will be the cash flow for year 1? The expected return. Now it will be 5% of what? The nominal value. Yes, 50. So 5% of 1,000 is 50. So if it is 100, 5% of 100, that's what you use. So if they tell you that the nominal value is 100, now that means the nominal value is going to be the coupon rate. That means for year 2 is going to be 50. For year 3 it will be 50. For year 4 it will be what? 1,050, because it's going to be the principal, because it's going to be redeemed in year 4. At the end of year 4, it's going to be the return plus the principal amount, which is on 1,050. Am I communicating? So let's calculate the discounting factor. So this discounting factor, what you use in the discounting factor is the yield. That means the yield. I've been telling you now, redemption yield, redemption rate, yield interest rate, everything is So at what? 7.8%. So you already know how to calculate the discounting factor. So calculate for this. So let me just take from the material directly. So because our time is fast approaching. We have someone should call 0.927, 0.859, 0.7, 0.9, 797. The fourth year is what? 0.7. So 739. So let's add it together now. Let's multiply now. Let's get 737. This one is 793. So let's multiply now. 50 times 50 times 0.927. Well, let's be fast. Well, 46.3. Well, let's be fast. 50 times 0.859. 42. Am I right? 42 points. 50 times 0.797. 39.84. 1050 times 0.737 is going to be 775.55. So add it together. So let's add it together. So if you add it together, it's going to give you 9. Now, so this is the market value of the bond. Are we together now? Now let me now explain something, because some exam question that they will give to you now. This yield may not be constant. What did I say? The yield may not be what? Constant. Meaning that, are you getting what I'm saying? Do you get what I just explained? I say the yield, the interest rate that we use for the discounting factor may not be what? Constant. That means for each of the year, it may be changing. They may give you different yield for different year. Because in bond, for each of the year, that means as the year is what? For the time of maturity, the yield is what? We have different yield for each of the year for bond. Now, well, your question will now be, why are we using a constant yield for the 4 years now? Meaning that this yield that was given to us, or the yield interest that was given to us, has been calculated using calculating the average weighted rate of interest. Average weighted interest rate. That means average weighted yield rate. And how do you calculate the average weighted interest or yield rate? You use what? IRR. So IRR has been used. Internal rate of return has been used to calculate. So what we are being given in this question is the IRR. Am I communicating? Do you understand what I just explained? Hello? Hello, do you understand what? Now what I'm saying is that in some question, they may give you the yield for year 1 to be 7%. The yield for year 2 may be 8%. The yield for year 3 can be 7%, and the yield for year 4 may be 5%. That's what I'm saying. That means each year has its own what? Yield rate. Are we together now? Each year has its own yield what? Rate. Are we together? Or let me say 9. Let me just use that one to buttress my point. That means you know that as the length of maturity is getting longer, what will happen to investor? Investor wants to demand for higher what? For higher interest rate or for higher yield. But however, when you see the yield curve, when you see the yield that is constant, that means the yield, this yield that is constant for the 3 or for the 4 period, it has been calculated using IRR, internal rate of return. You know how to calculate internal rate of return?
Yes.
So how do you calculate it? So
Internal rate of return is the NPV, is the return that equates NPV to be 0.
is 0.
So we use two discounted factor.
The lower and the higher rate.
IRR.
That means the rate that will provide the positive and the negative NPV. So I'm coming. I want to show you something here so that you understand what I'm saying. I'm coming. So I'm explaining that the RRR is the average rate of interest or the yield or the interest yield for a bond. That means if you use the RRR to calculate the discounting factor and to get your present value, and if you use the individual yield for each of the year, you are still going to have the same answer, similar answer. So let's look at this question now. In page 523. So we look at it quickly. So look at it now. The same question. They now say for year 1, they said the required return for year 1 is 5%. The required return for year 2 is 6%. And the required return for year 3 is 7%. And the required return for year 4 is 8%. That means as the length of maturity is increasing, also the rate of return is increasing. Am I communicating? Now look at this now. Now, let's say the bond, the question we solved initially. Let's say the bond, okay. You know, don't forget that the nominal value, what is the nominal value of the bond? You say it's 1,000. The coupon rate, what is the coupon rate? I think 5%, right? Don't forget that this is the yield. The yield interest or rate for each of the year, unlike the one they gave us that is constant throughout the year. So you may be given a question and the expected return for each of the year is not the same. So you don't need to bother yourself. Don't forget it's 4 years. So just do it like this. Here, the cash flow, the discounting factor. Are we together now? Now, year 1, year 2, year 3, year 4. What will be the cash flow for year 1? Don't forget that the coupon rate is used to calculate the cash flow. What is the cash flow for year 1? So 5% of the nominal value. What is 5% of nominal value? So 50. So we have 50, we have 50, we have 50. And in year 4 is going to be the redemption date. At the end of year 4 is going to be the redemption date. So the principal, the nominal value is going to be P. So we have 1,000 plus what? 50. So it's going to give us 1050. So let's look at the discounting rate. At discounting rate at each rate. So for year one, what is the yield for year one? 5%. So it's going to be 1/1 plus 0.05 raised to power 1. So what are you going to get? Where? What are you going to get? Someone should be fast. 0.952. 0.952. So for year two now, year two is 6%. So it's going, we are not going to use 5%. It's going to be 1/1 plus 0.06 raised to power what? 2. So what are you going to have? 0.890. So let's for year three. Year 3 is 7%. So let's change it to 7% raised to power what? 3. 0.8116. So let's go to year 4 now. Year 4 is 8%. It's going to be what? 0. What? 735. So let's multiply now. So let's calculate the present value. So 50 times 7 point what? 7.70 what? 762, right? Okay. So 50 times 0.890. 44.5. 771. So add it together now. So they calculate the market value of the 904. Is it similar to what we calculated using 7.87? Yeah. So if you are asked to calculate the RRR for this investment, this is the formula for RRR. Let me remind you again. So this is the formula for RRR. So RRR formula, I don't know how you write your own RRR formula. It is return of A plus the NPV of A minus NPV of A minus NPV of B brackets the rate of B minus the rate of A. So what is the rate? What is, when you see A is the lower rate, while B is the higher rate. I'm just reminding you, I know Mr. Ezekiel could have put it through this now. So you may be asked to calculate the expected return for the investment. So you need to calculate the lower rate. Now, which one is going to give the positive? Which one is going to give the positive value? Is it the lower rate or the higher rate? So the lower rate will give the positive NPV. Positive NPV. I'm just giving an example, and the higher rate will give a negative NPV. So let's move into, sorry, let's do this lastly, because you may be given some question. So let's look at this question. I wish I could change this question and give you guys. You know what? I will give you this question and I will change it. Let me try to change it. So I will give us an assignment. I don't want to waste time. The answer is there, but I will change it. I will change some things here so you calculate it. So page 527, there's a question there. So but the question is not hard. It's based on what you have been doing. So it's just that they needed you to calculate the IRR, what do you call, the internal rate of return. That means they gave you the interest. That means the yield interest for each of the year is not the same. They now say you should calculate the average weighted yield rates. So what are you going to use? You use IRR to calculate it. So please look at that. Maybe what I will do is that, let me just change some figures there and I will give you as an assignment. So let's go to page 529. So the maturity for the firstborn is what? Is 1 year. And let's calculate the cash flow. Now, the cash flow we are going to calculate based on the coupon rate, right? So, and the coupon rate in this question is 6%, right? Are we together? 6%. So, they said the bond is at par. So, whenever bond is at par, what is that? Is 100. Are you getting what I'm saying now? When bond is at par, is what? What do I call it? 100. So that means the nominal value of that bond is 100. Are we together? Now, I was explaining something. I think I skipped it. See, let me explain why if interest increase, bond, the value of bond increase. They believe that when it comes to bond, the basis for bond is 100. Now, and in this 100, there is interest in it. Let's say there is interest, the interest on this bond is 6%. That means the value is 100 minus 6. That will give us 94. While the interest rate or the yield is what? 6. Can you see now? Let's say the interest is 8%. What will happen? What will be the value of the bond? What will be the value of the bond? It will be 100 minus what? 8. That will be 92. Can you see now? That's why we say there is inverse relationship between the price of a bond and the what? Interest rate. That means as the interest rate increase, the price of bond what? Decrease. And as interest rate decrease, the price of bond what? Increase. So at par is 100. So 100 times, what is the coupon rate? 6%. That will be what? Hello? That will be what? 6. Now, what is the discounting factor? Do we know the discounting factor? No. Because we are going to need the yield curve or the yield rate to calculate the discounting factor. So what's the formula for discounting factor? 1 what? All over 1 plus what? R. Raised to power what? 1. Now, the present value, we don't know it. But however, they have given us the market value of that bond to be what? 102. So if the maturity date is 1 year, am I communicating? What is it? That means if the maturity stage is what's it called? If the maturity or if the market value is 102, what will be the present value here? So it's going to be 1. Am I communicating? Are we together? It's going to be 102.
102.
It's going to be 102. Are you getting what I'm saying? Because we don't have. So if the market value is 102, it means that this what is here is x minus what? We don't have anything. So automatically x is 102. I'm just giving, don't worry, x is 102. So we can use this now to calculate our discounting factor, our interest rate. So how do we do that now? So we can do it by doing it like this. So we know that when we multiply our cash flow times discounting factor, we are going to get the present value, right? So we know 6 times 1 all over 1 plus r raised to power what? 1 equals to what? 102. So we know that it's 6 over 6 times 1, 6 all over 1 plus r equals to 102. So what do? We cross multiply, right? Am I right? Are we together? We want to get the R. Don't forget that the R is redemption yield or yield rate. That's what we want to get. We are not giving in the question. And because we are not giving in the question, they said we should construct yield curve. Can you construct yield curve without the yield rate? Do you understand what I'm saying, sir? Okay. So you have this times this. Let's say you have 102 brackets 1 plus r 1 plus r equals to 6. So what do? Divide both sides by what? By 106. So 1 plus r equals to 6 divided by 102. What do you get? Yeah, someone should be fast. Let's be fast so that we can. 6 divided by 102 is what? Yeah.
0.058.
0.058 588. So what do? R is now equals to, so just do it like this. Let this one come here. 1 minus 0.0588 equals to what? R. So what will be your R?
0.9412.
Is 0.
0.9412.
Is 0. Is 0 point.
9412.
Are you sure? Someone should confirm. Yeah, I'm with you.
I think we are given the redemption value as 100 naira. That's the nominal value. And the interest is.
So what I'm saying is that for it is 1 year. This question is for 1 year. That means the return and the principal is going to be the cash flow for year 1 because its maturity date is for 1 year. So it's going to be 106. That means the nominal value, which is 100 plus 6, which is the coupon rate, is going to be 100. So this is how you calculate it. So let me quickly. So you do it like this. This times this, which is this, is equals to 102. 102 is the market value. So when you do it, you get it like this. So there's a mistake in the previous one we've done. So don't let me waste time on it. Let's go for year 2 now. So let's go for year 2. So we know that year 1 is 3.92%. So let's go for year 2 now.
So
B now. So we have bumpy, we have what? Year 1 and year 2. So what's the coupon rate? 5%. So 5% of 100. 5% of 100. 5% of 100. 5. Because the maturity day here is year 2. That means the principal, which is 100, because it's at par, plus what's it called? Plus 5 is going to be 105. Now look at it now. we have gotten the what's it called, the discounting, the rate for year one. What was the rate for year one? To be 3.92. Are we together now? So
Yes, sir.
let's count the discounting factor for 3.812. 0.032. That's what we got for year one. Oh. No, we've gotten the rate for year one, raised to power 1. What will be the discounting factor? Oh yeah, be fast.
0.96.
0.9.
9623.
So this times, what will be the value? 5 times 0.9.
No, that is 6, not 5, sir. That is 6, not
0.96.
No, I mean the cash is not 5.
Is 5. Look at the question. The coupon rate for bond B is what? Is at 5%.
This is 5%.
It's 5%. You are not using 6 again. Do you get what I'm saying now? It's 5%. Oh yeah. Do you understand it now, sir? Go to the question. You see, it's 5%. Now, oh yeah, multiply it. 5 times 0.
4.812.
4.812. Now, don't forget they've given us the market value. What's the market value? They've given us the market value. 101. Now, what happens is that the rate for the second year, we don't know it. But we can calculate the present value. What will be the present value? That means the present value will be the difference between this and this, right? So let's say this one is X now. It means 4.82 plus X.
4.812 or
4.81, Abi?
Yeah, 4.812 or you use 4.81.
Okay, 4.81. So 4.81 is equals to 101. Are you getting what I'm saying now? When you add it together, it should give you 101. So that means X, this place now, we don't know it, but we can calculate it. X is now equals to 101 minus 4.82. 4.81. What would that give us? What would that give us? Yeah, let's be fast. 96.19. So this means that what will be here, the present value is 96.19. But we don't know what to multiply with it. We don't know this. We don't know the E. So how are we going to calculate it? So just write the formula there. It's going to be 1/1 plus R raised to power what? 2. So just extract it. It means 105 times what? 1/1 plus R raised to power what? 2 equals to what? 96.919. Because when you multiply it, that's what you should get. So you are having 105 all over 1 plus 1 plus R raised to power 2 equals to 96.19. So what do you do?
Cross multiply.
Are you going to cross multiply?
We first need to do the square.
So let's cross multiply. So, but before you do that now, just what you do first is for you to calculate the what's it called? So let's cross multiply. So that will be, let's cross multiply first. 96.19 equals to 1 plus 2 equals to 5 So what do? Divide both sides by what? 96.19. Divide this one by 96.119. So this will cross this. Am I communicating? So if that's cross that, it means you will now have 1 plus r raised to power 2 equals to 105 over 96.19. So what do you do now? For you to remove this, that means square both sides. So square root of 1 plus r raised to power 2. So this will cancel this. So this one will now be square root of 0.596.19. You understand what I did there? Your simple mathematics when we were in school. So when you want to remove the raised to power 2 here, you find the square root. Am I communicating? This square root. So you divide both sides. So you now have what is in the bracket. Am I communicating now? So you now have 1 plus r. So what is the square root of this? The square root of 0.5 raised to power 96. I say raised to power divided by 96.19. What do you have? Yeah, let's be fast.
1.0447.
Have you find the square? 1 point what?
1.045.
So it's
447.
so it's correct. 1 point. Oh yeah, 1 point.
0447.
I don't understand. What do? Do you write the square root and divide it, or first divide 105 divided by 96 and find the square root of the answer? What's your answer? Oh yeah.
1.045.
1.045. So let's now find the r now. R will now be 1.045 minus 1. So r is equals to 0.0445. Is it correct? Is it correct? Okay. Because of approximation, let's do this now. So r is equals to 44.5%. Do you see now? So you may be given some question where the id will not be given. So we already know that this one is 4.5%. So if you are now for year 3 now, so can you do for year 3? Can you guys do it that one as an assignment?
Where we have confusion is this one that we are able to know that we will do square roots.
That one you will use shift now. You know how to press your calculator. There's something you press. I think 3n square something on your calculator. I don't have scientific calculator here. I could have showed you. Some people know how to press it. There's something like I think there's something like this.
I show also.
I think there's something like this in the calculator. You see, second option.
To that stage of square root, what are we going to do for that one?
It's not going to be square. That one will be cube.
Second function, exponential.
Yes, thank you, exponential. Yes. So it's going to be 3 exponential. That second function of what you just mentioned is something like this.
You will put 3 at the back of this square.
I think you write 3 first. You will now write 3 exponential this now. You will now put what is inside the bracket there.
Oh, okay, yeah. That's good.
Yeah. So for year 3, it's simple for year 3. Look at it now. So let me quickly. What's the coupon for year 3? So we have 4, right? We have 4 because it's 4. So 4 times the 100. We have 4, and you have 104 here. Now we already know the discounting factor for year 1, which is 1 over, I don't want to waste time on here, plus R. Our R is 0.0392, I think so, raised to power 1. So you calculate this, you multiply this, and you get this. So for year 2, it's going to be 1 plus 0.045 raised to power 2. Whatever you get, you multiply it by 4, you get your present value. So for year, so they've given us the market value. They said the market value is 95. So someone should do this and multiply it by 4 and see what you get. So let's do that. Oh yeah, 4 times this. Oh yeah, let's do it fast. Let's do it fast.
3.85.
The present value. 3.85. 3.8.
85.
Yeah, 4 times this. Yeah. Someone should do the second one now. Yeah.
3.698.
3.668.
698 or 3.7.
3.66.
3.7
3.
Yeah, I got 3.66.
Okay, 3.66. So look at it now. For year 3, do we know the rate? We don't know the rate. Am I communicating now? We don't know the rate, but we can calculate the present value. They said the total present value is 97. So how do we calculate the X here? We don't know what will be here. We don't know the R. So we don't know the R. So but we can get this. So 3.85 plus 3.66 plus X, we don't know it. Everything, when we add it together, it should give us 97, but we don't know it. So add this together. Yeah, what do you have? What's your answer? So this plus
89.49.
What do you call it, sir?
89.49.
So your X is 80
9.
point what?
49 or 89.49.
So that means 89.49. So you can now calculate now. So this times this will give us 104 times 1 plus R all over 1 plus R raised to power 3 equals to 89.49. So what do you have? 104 all over 1 plus R raised to power 3 equals to 89.49. So cross multiply. So when you cross multiply, you have 89.49 all brackets 1 plus R raised to power 3 equals to 104. This one should be 104 directly. So let's look at now. Divide both sides by what? By 89.49. 89.49. So this will cancel this. So after that, find the cube root of 1 plus R raised to power 3 and cube root of 104 all over 89.49. So this will cancel this. Am I communicating? So calculating, someone should press it in his or her calculator. So what do you have? 3 points.
234.
3K. Can't be 3. Oh. Okay. So if you do that, that means you have 1 plus R is equals to what? 1.0514. 1.4. So R is equals to what? 1.0514 minus 1. So your R is equals to 0.0514. So automatically your R is 5.14%. Can you see now? Please go and learn how to press that thing in your calculator. Please teach yourself. So teach yourself, please. So we'll stop here.